countless proofs and proving how things work in algebra and geometry, but the specific one we're hitting today is the algebra concepts. Now, algebra proofs are a lot easier for you guys because you've been doing algebra problems for a long, long time. All right? However, the geometry proofs would be harder. We're not actually going to hit the geometry proofs this year just because of the way that testing hit us and me being out a couple of days. It's going to drop it back. But I just want you to introduce the fact of proofs. So I'm introducing the facts of proofs with you guys. But we're using the algebraic properties to prove it. You've seen them before. We're going to let A and B and C be real numbers, numbers that are on the number line. If A equals B, then if you're doing the addition property, the property of equality means if you do it to one side, you have to do it to the other. So if I add a number to one side, say I add C to one side, then I have to do it to what? To the other side. All right, that's called property of equality of addition, or additive property of equality. So the subtraction property, if I take the original numbers and I subtract a number from one side, what do you think I need to do on the other side? Do the same thing. Okay, that's properties of equality. You've done it. You may not have known the actual name for it, but you've done it. Or you should be fairly familiar with it. Multiplication property means if I multiply a number to one side, got to do it to the other, right? Division, now C cannot be 0. That's the only number it can't be. But if I take a number and divide it by C to one side, I must do it to the other side. Okay, there's a limitation there. C can't be 0. Does anybody know why C can't be 0? Good. You can't divide a number by 0. You get undefined, right? Because no number times 0 is going to give you the original number. Okay, these are some that you've done. You may not be as familiar with them. Reflexive property just means that a number equals itself. Okay? A number equals itself. So you can kind of switch things around. You know, like if you get x equals 1, you can rewrite it as 1 equals x, and that's the same exact thing. Symmetric property. If you're given this, if a number equals something else, like x equals 1, then you can reverse it, right? And you still get the same number. You get the same answer. Reflexes it as the exact same number, exact same thing. Symmetric means you can reverse the order. Transitive makes sense. You just don't say it very often. But if I said if A equals B and B equals C, then what do I know? A equals what? Good. That's the reflexive property. You can take two pieces of information and make something else out of the third. Make a conclusion based on the third piece. All right, on substitution. If you're given A equals B, A equals some number, then you can replace B for any number in the equation, right? Or vice versa. Then you can replace, let's use replace instead of substituting so that you know it in your definitions. Depending on how big the problem is. Okay, so it can be replaced for B in any equation or expression. So you're okay with these properties, you're going to be using those in your proofs. So make sure you're familiar with them. Same way it works with the geometry proofs, except that, you know, the properties and the theorems and the things we've been stating, like the additive, you know, you're adding your segments together, addition postulates, you would use those. You're just not as familiar with them in the terms, but you could solve them the same way. All right, so here we go. We're given the problem, negative 2x plus 1 equals 56 minus 36. And we want to write a reason for each step. Here's how you write it. Now, I do 2-column proofs because I think they're easier to see, especially when you're starting out. In a 2-column proof, you're always going to have your statement and a column for your reasons. And you're going to label it that way. You're going to write statement in one column, reasons in the second column. This is how you're working out your problems today. All right, so whatever you're given, okay, whatever you're given, that's where you start. That is your reason why you start there, because you're given it. And your statement is whatever it is. And this happens to be negative 2x plus 1 equals 56 minus 3x. All right, now using algebra, what would you normally do? Get the x's on the same side, right? So I'm adding 3x to both sides. Now, what property was that called?
The addition property.
What kind of addition property? Of equality. All right, it's got equal in it, makes it equal to equality. Okay, now you wouldn't have to show the plus 3x, I just did that for your benefit. And the actual proof, you're really not going to show that. You're going to write whatever it is, 3x plus negative 2x is just x, right? So x plus 1 equals 56. That line right there is what you're going to see. X plus 1 equals 56. And you got that because of using the addition property of equality. Did I lose anybody in the algebra? All right, now what would you do in algebra? Okay, so we're going to subtract 1 from both sides. Now, what property would that be? Good. So subtraction property of equality. We're really subtracting 1 from each side, but we don't really show it. It's just a step we know what we're doing. If I subtract 1 from 56, I get 55. Any questions? Could you do that? Now, they do get more demanding in geometry. I'm telling you, it's just a little bit harder because you're not as familiar with it. You had a year of algebra, right, to get familiar in how to solve the problem. All right, now if you're doing geometry proofs, you don't really, you got to take all the information that you've learned this year. You haven't used it as much, so it's a little harder, and you have to think through them. Yes, sir? You don't have to show algebra work, like the adding on each side or the subtracting on each side. Okay, you can just show me the next step. All right, so you don't have to show me the plus 3x's, but you're going to show me what comes after it. All right, now you can. I'm not going to take off if you do. All right, but just realize it doesn't get a name for it. You can just kind of put it up in between. Or if you want to skip a line, but it doesn't get a reasoning for doing your step. It's the result after it. Your solution step has a result. All right, so here we go again. I'm given the problem, 12x minus 3 times the quantity x plus 7 equals 8x. I've got my statements and my reasons. Now on your paper, make sure you start with statement and reasons. That's where you're labeling it. Now, why did I put that? What's the reasoning for putting that there? It's given. All right. In algebra, what would you do first? Parentheses. And what's that parentheses called? Good. And that's your reasoning. It is distributive property. Now, we didn't talk about that a while ago, but good. You remembered it. Good. Good, good. I'm glad it had it on there. All right. So, you get 12x. Does anybody need a refresher on what distributive property is? That negative 3 gets multiplied by the x, and the negative 3 gets multiplied by that positive 7. All right, so negative 3x, negative 21, because a negative times a positive is a negative. Good. Most people forget that second one, so make sure you got it. Now what do we do? Okay, you could add 3x to 8x, but what could you also do? you can combine like terms, and 12 minus 3x is
9x.
9x minus 21 equals 8x. Now, what happened there? Now, we do right now, but what happened between that step and that? What's the reasoning? Okay, subtraction property of equality means I go across the equal sign. Did I? Okay, so it's not just a subtraction property. It's got subtraction property of, and there's nothing because I didn't do anything of that kind. I just subtracted. You could write combine like terms, or better yet, simplify. Okay, so anytime you can combine like terms, you just say simplify. Or if you reduce the fraction, you can say simplify. All right, now what do we do?
Take 9x over the 8x.
Good, you're going to move the 9x to the 8x. What would we do in order to do that? Subtract. And so that is subtraction. And if you want to shorten it, that's fine, but don't put SUB because that could be substitute. Subtraction property of equality.
We just put subtraction equality.
It should be property. You can shorthand it. All right, so subtract the 9x from both sides, so you're left with negative 21 equals negative x. All right. Now there's a couple of things to do to here. Anybody know what to do? Divide by? Okay, you can divide by -1, you can have multiplied by -1. So you're using division property of equality. So now I got positive 21 equals x. Does anybody know what you have to have in your final answer when you write your answer to your equation? X should be on what side? The left. So I really want x equals 21. Does anybody remember what property that is? Okay, it could be the reflective, but better yet, it would be the symmetric. Reflective is more like something equals the same thing. Okay. Good. So now you're just realizing, hey, I'm using all these properties that I use in algebra. Kind of made sense to me. I just did it. But now these are the reasonings why you did it. Let's see what else we got. So here we go. The Fahrenheit and Celsius temperature scales are related by a formula. F, standing for Fahrenheit, equals 9/5 times the Celsius degrees plus 32. All right, we want to solve the formula for C and write a reason for each step. So you've got your statement and your reasons. What's the first thing that I write? F equals 9/5 times C plus 32. And why did I write that? Because it's given. Good. All right. So if I want to solve for C, my first step is to get everything that's on the side with C to the other side. What's my first step in this problem? Subtract the 32. So subtraction property, right, of equality. When you're subtracting 32 from both sides. So really you've got F minus 32 equals 9/5 times C. All right. Now what would you do? And our reason is subtraction property of equality. Now in algebra, what would you do to get C by itself? No distributive. I want to get rid of that 9/5. Okay, multiply what? 9/5 wouldn't cancel out 9/5. You multiply by the reciprocal. Really, you're dividing by 9/5, right? But you can't divide by a fraction. You have to multiply by the reciprocal. Good. So you multiply by the reciprocal. So that, I would have taken either property. You could have said division property of equality, or the true one would be multiplication property of equality. And you're multiplying by the reciprocal of 9/5, which is 5/9. So you've got 5/9 times f minus 32 equals c. Because 5/9 times 9/5 give you 1, and 1 times c is c. All right, now again, we like to write it where c is in front. So c equals 5/9. And this is not the only way that you could wrote it. You could have distributed, but there's no point. And what property is that called? Symmetric. Very good. Okay. So now that we have solved for Celsius, I want to find temperatures that correspond to the following Fahrenheit degrees. So if it was 5 degrees Fahrenheit, what would it be in Celsius? Well, what do you think I do? Yeah, I just substituted in. So I've got 5 minus 32 times 5/9. And you know, if you put it in your calculator just the way you see it, now I would always do 5/9 in parentheses, just so you don't make a mistake, and then parentheses 5 minus 32. And you get negative 15, which is negative 15 degrees Celsius. Okay, and you put a little c behind it so you know it's Celsius. All right, and then we do the same thing. We go all the way through. We do Celsius for 32 degrees Fahrenheit. Well, 32 minus 32 is 0, and 0 times 5/9 is 0. So anytime it's 32 degrees Fahrenheit, it's an easy one to remember. It's 0 degrees Celsius. There's certain ones in chemistry and physics that you're going to learn. 32 would be one. Boiling point, that would be freezing point. C equals 5/9 times 95 minus 32. And you get 35 degrees Celsius. And you go on through. And I'm going to let you do these on your own. You're going to do 5/9 times 140 minus 32. And you're going to do 5/9 times 212 minus 32 and find your answers. Okay, so my question is, how does the Celsius temperatures change as the Fahrenheit temperatures change? In other words, when the Fahrenheit temperature increases, what happens to the Celsius temperature? Does it decrease or increase? It increases. All right? So as the Celsius temperature changes, so does the Fahrenheit temperature. So as increases, so does the Celsius temperature. Okay, as one increases, so does the other one. So if you were looking at it as a graph, it would gradually increase, giving you a slope, right? Couple more. If I need more time on this one. we found them, right? This is just your slide of fixing your answers. So properties of equality. You've got segment length, reflexive property. Okay, this is the only thing that's different. Instead of dealing with algebra, we're dealing with the segment length, right? So reflexive property, we talked about, it's the same thing. So the length of AB needs to be the same thing, right? It's going to equal itself. So segment. Remember, it doesn't have the line over it because we're talking about the length of that segment, not just the line segment. All right, if an angle, if I'm talking about an angle, angle A is going to be equal to itself, right? So these are just using the same type of properties that you're using it for angles and line segments. All right, symmetric. Remember, you can just replace it. If AB equals CD, then you switch it. CD is going to equal AB, right? Same with the angles. If the angle A equals the measure of angle B, switch it around. The measure of angle B is going to equal the measure of angle A. These should be measures. I just left them off. Transitive, same kind of process. If the segment AB is equal to the length of the segment CD, and the length of the segment CD is equal to the length of the segment EF, then AB is equal to? Right, you take those away and you're left with EF. All right, same with the angles. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, the measure of angle A is equal to what? The measure of angle C. Good? When you're talking about angle measurement, you've got to use that little m and the angle. That's how you have to deal with proofs. You've got to name them and label them correctly. I'm going to erase these lines here because I was talking about CD, and I don't want you to think that they were the line segments, AB and EF. You ready? All right, use the information at the right to find the measure of angle 1. All right, here we're dealing with geometry. A little bit harder, right? We're given this, all this stuff right here. But I want to find the measure of angle 1. So my end goal, my last thing that I want on my paper is the measure of angle 1. Now I can use all this information here to answer it. So you always start with statements and reasonings, right? And sometimes you may be repeating yourself, but here's the deal. Anything that you're given, you can put all at the very top and then use it, or you can do it as you need it. I like putting it all on top, just so that I can use it anytime I think of it. So I know the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 360 degrees. Okay? I'm going to start with that. I will. And the reason that I wrote it is because it's given. But I also know that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 4. Very interesting. And that's given. They also tell me that the measure of angle 1 equals the measure of angle 4. Also interesting. Okay, I've been doing this for a while, so I can clearly see what I need to do. But I want you to take a time to look at it and to think, what can I use? The first statement that I'm given kind of 4 variables. Measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4. There's 4 variables. I can't solve an equation, even though it's equal to a number, with 4 variables, not without doing some other things. My goal is to get the measure of angle 1. But I know these other 2 things. How can I use those other 2 things to break it down? Okay, but they're not all equal. Okay, I can't divide 360 by 4 because they're not all equal. So I've got 4 different variables. How can I break it down so I only end up with 1 variable?
Well, 2 plus 3 has to equal 4, so figure out what 4 is. Figure out what 3 is.
Okay, so I can't figure out what 4 is yet, but you made a good point. The measure of angle 2 plus the measure of angle 3 is the measure of angle 4. So what else can you do with that information? I'm sorry? Good. I'm sorry? He was saying that, the measure of angle 1 is going to be equal, or excuse me, the measure of angle 2 plus measure of angle 3 is also going to be the measure of angle 1. That's fine, and he could have used that step to start with. All right, we can do that, but there's something you probably want to do first. That's fine, let's do that. So he said the measure of angle 2 plus the measure of angle 3. Okay, since it's the measure of angle 4, and this is the measure of angle 4, it's going to be the measure of angle 1. And he just used the transitive property. Okay, it's not where I would have started, but that's fine. It still works. All right, so you use the transitive property on that. Now what would you do? You still need to use that first statement. And how do you think you're going to use it? What do you know? Okay, all of them added to equal 360, right. But I've got to do something else with that left-hand side. Good. We know the measure of angle 1 and angle 4 are equal. So what can I do? You can make it 1 variable. Yes. So because we're looking for the measure of angle 1, I'm going to leave this one alone. All right? And he says the measure of angle 4 is really the measure of angle 1. So I'm going to go ahead and rewrite all this stuff. Measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, but I replaced 4 with 1. Now what property did I use?
Symmetric.
Not symmetric, one that you normally know. How about substitution? Okay, so use the substitution property. Can you do anything else? Now I'm down to 3 variables. Bless you. How can I get rid of these 2? Well, if I add them together, what are they? I kind of know what they are. I kind of look at your other stuff that you've written. They're the measure of angle 1. Good. So can I replace them and say that they're the measure of angle 1? Okay, and what would that be called? How about substitution again? You're just replacing it, right? Okay, so you did substitution property. How many measures of angle 1 do you have?
3.
So you have 3 measures of angle 1. Excuse me, and they equal 360. I left that off. You need that. 3 measure of angle 1, and that equals 360 degrees. So this is called what step? This one's kind of hard, but think about it. When you combine like terms, what do you get? What's that called? Simplify. Good. And that's what we did, even though we're dealing with, it's not variables that we're used to, but it's still a variable, something we don't know what it is. All right, now what do you do? You divide by 3. So the measure of angle 1 equals 360 divided by 3, which is 120 degrees. And what property do we use? So if you were doing this on your own, would it look exactly like this? It would?
No.
Okay, it doesn't have to. When you're doing proofs, yours and your neighbors could be different. Okay? I could have took a different approach, and that's the way that I took it on my paper. But that's okay. You would have had different lines, different things. But as long as you did it mathematically correct, justified your answers correctly, and got the end result, it would be okay. All right? Did you have to do it this approach? No. But it was a good approach. It was actually a step quicker than mine. All right? One more. Go back. All right. So in the diagram, B is the midpoint of the segment AC, and C is the midpoint of the segment BD. Show that AB is equal to CD. Where do we start? If you're doing a 2-column proof, where do you start?
Well, AB and CD are equal to each other.
Okay, wait on it. What do you start with? Your statement and your reason. You always start there. And what do you start with on your reasons and your statement? What is given? All right, what is given? B is the midpoint of AC. All right, and another one, C is the midpoint of BD. All right, and the reasons for those are they are given. All right, now you're doing great because you're thinking through, what do I know about midpoints? And you said what? Okay, so AB is equal to what? BC. Okay, so we know this, and I'm going to write it up here.
C is the midpoint of BC. It's supposed to be BD.
Excuse me, thank you. It's supposed to be BD right here. So C is the midpoint of BD. All right, so we know that AB and BC are congruent. They're the same measurements. What else do we know?
CD and AC are.
Okay, and so you know, careful, you know C, you know that BD, say it again.
BD is equal to AC.
How do you know that?
Because,
Can't go by looks because I could have just drawn that randomly.
because
You don't know that.
well, AB and CD are equal, so that means that
You said AB and BC are equal.
then CD is equal to AB.
Okay, there you go. CD is equal to, what is it given?
AB.
It doesn't tell you that it's equal to AB.
Yeah, that's what it says.
No.
Oh.
We're saying show that. That's what you're going to have to show. Okay, so we've got the first one. The first one you said B is the midpoint of AC. And then you tell me this bit of information. You tell me that AB is equal to BC. And do you know the reasoning why that is the case? Why those segments equal? Okay, midpoints are equal, and that's called the midpoint theorem. Okay, because of the definition of midpoints, or let's do definitions. Definition of midpoint. Right. So you know that bit of information. All right, what else do we know? Now let's do the C as the midpoint of BD. Okay, how did you get that information? What do we know about C being the midpoint of BD? What do we know about that? We're only looking at this segment right here.
It must be equal on both sides.
Okay, C is the midpoint, and when the midpoint's given, what do you know?
Equal on both sides.
It's equal on both sides. So what are those sides?
BC is 8.
BC is equal to
CBC.
CD. And why is that? Because it's the definition of a midpoint. Good.
You have to look at trick squiggly things.
It's a DEF definition. So you could write out definition or shorthand. All right, so we know this bit of information. I want this as my final statement. That's what I want to prove. How do I get there?
A, B, C, D are equal because they're all midpoints.
Okay, AB equals CD is true, but you can't say because they're all midpoints because there's not anything dealing with midpoints there. Is there a property where I can say that? What property? The transitive property. Okay, be careful, because when you're dealing with proofs, sometimes you know it in your head what it's going to tell you what the answer should be, and you're going to try to get there by just getting there. Like, we're saying, well, we know because by the looks, we can tell that it's going to be, that doesn't work. You've got to back it up with algebraic ideas, all right? So be very careful. Some of them you have to think really hard, and not everyone can do proofs. You're going to try your best. You're going to attempt every one that you do, okay? You're going to try. Sometimes the logic behind proofs takes time, and some people get it really quickly, and some people take a long time, okay? And you'll really work at it. That's why we're not going in depth on it. We're not in an honors class, but I am going to introduce it to you in case you have it in college. You can know what they're talking about and grasp it, okay? So it's just an introduction to proofs. Yes, your question. For how fast?